Is the continuation of lesson 2.04. We have 4 more problems to do on this. Had a little problem recording this yesterday, but that's been resolved. So let's go ahead and finish this up. And this assignment is due on Friday. Okay, I want to put you through a little, just a little lesson or a little drill here to understand that if you're given a 0, okay, that is one of those numbers that we've been finding, like in this problem above, it was the 2. It was what made this go to 0. How do you get the actual factor? And it's a pretty simple process, but I want to be sure you can see what it is. So I'm going to give you some examples over here on this side. If the 0 is 1, if it's -3, if it's 5, if it's -7, what is the factor that would be associated with that? It's just working backwards from here to the factor. So let me actually show you that example up here. If you were given this as a 0, what would be the factor? And the factor would be this. It's the binomial, that's a binomial, that this would make go to 0. The binomial that this would make go to 0 is x minus 2. It's the simplest one. There's others that you could think of, but this is the simplest one, the most simplified one. So if you were given, let's just skip this one, it's just a messy number. If you were given this, the -2, what factor would this make go to 0? What would it belong to? And it would belong to this factor right here, because this is the factor that this would make go to 0. So I put a -2 in there, then this goes to 0. So instead of asking you what number makes this x, this entire term, go to 0, which is the question we've been asking, and it's this number, I give you this number and ask you what is the factor. This is called the factor, this binomial, and the answer is it would be x plus 2, because if you put the -2 in there, this would go to 0. So I'm just going to give you a few to practice on here to be sure you can spot that. So if this is the 0, what is the factor? So in other words, I'm going to come up with some binomial, x, and it's going to either plus or minus some number equals 0. So if I put this in for x, what has to go here to make this entire expression go to 0? The answer in this case would be -1. So this is the factor for which this is the 0. If I put a 1 into the x, then 1 minus 1 is 0. Okay, it's just kind of working backwards, but it can kind of be a little bit of a mind twister the first couple of times you do it. How about if I give you this? What I'm going to put here, it's going to be a plus or minus some number. What would make this, what would turn this to 0? So if you put -3 in for x, what would this number have to be that makes it all go to 0? And the answer in this one would be +3. So this is the factor for which this is a 0. So I put a -3 in there, -3 plus 3 is 0. That's a true statement. Okay, what makes this a true statement? So if I stick 5 into x, what does this number have to be so that the whole thing goes to 0? The answer would be -5. So this is the factor for which this is the 0. So 5 put into there, 5 minus 5 is 0. Let's just do one more. Okay, so what factor is this the 0 of? What would I put there so that when I put -7 in for x, the whole thing goes to 0, and that would be +7. Okay, so you notice the pattern. It's always the negative, this number with the opposite sign. So 1 minus 1, -3 plus 3, 5, -5, -7 plus 7. Okay? So then when I ask you, this is a 0. If that's a 0, what is the factor for that? And the answer would be if I put a 1 in for x here, what would this number have to be? What that would make this go to 0? The answer is -1. So this is the factor for which this is a 0. Okay, the remainder theorem simply says that if you take this number, whether it's a 0 or not, and plug it into this equation, So that's what f of 1 means. It means you're going to take this number and plug it in there for that x, and that means you're going to plug it in for all the x's. That the remainder, that the answer, what you come out with, will be the same as the remainder if you divided it, did a synthetic division or any kind of division with this factor. So let's just do an example and you'll see. So the remainder. Okay, so the remainder, if you do a division of this into this, will be the same as if we simply took this number and plugged it in. So let's prove it. All right. I'm going to do it through. I'm going to give you a little practice on long division here. Okay, so here we go. So I'm going to take this factor that I got from this. This is the 0 of this factor, and I'm going to do a long division here. Just one more time on this, okay? I'll do the long division kind of fast, because we've done a whole bunch of these on the last lesson. Okay, so what we do is we say, what do I multiply this by to get x to the third? And the answer is x squared. And it goes in the x squared column here. So x squared times x is x to the third, and the x to the third goes in the x to the third column. It goes here. And remember, what you do is you're going to subtract. So I'm going to put a minus sign in a parenthesis, open a parenthesis. Now x squared times negative 1 is negative x squared. Now I'm going to close the parenthesis. Now I do the subtract step. Remember, this first term always cancels out. It always goes away. So this negative becomes a plus x squared. So 5x squared plus 1x squared gives us 6x squared. So that's the subtraction step. And now the pull down step. You pull this down. Again, I'm going kind of fast because we've done a lot of these already. X. What do you multiply x by to get 6x squared? Well, you're going to need the 6. And you're going to need another x. X times x is x squared, so 6x. So 6x times x gives you 6x squared. So again, so that's the multiplication step. Okay, and then 6x times negative 1 is minus 6x. Okay, so now that's finishing the multiplication step. 6x squared minus 6x squared, this goes away. And negative is positive 6x. So 2 plus 6x is 8x. That's the subtraction step. And now we're going to pull down the 8. Minus 8. Okay, x times what gives you 8x? Well, that would be 8. Plus 8. 8 times x is 8x. And we're going to put the minus sign in the parenthesis. And 8 times negative 1 is negative 8. Okay, so 8x minus 8x goes away. And negative 8 is positive 8. So minus 8 plus 8 is 0. So we're all done. That's the end of this problem. And we have a remainder of 0. Now we could have done that using synthetic division. By taking, remember what you do, you take this and you flip the sign of it and to make that from a negative 1 to a positive 1, but that's just simply the number you were given here. That's the 0 here. So let's go ahead and do that. Let's take that 1. Again, the way we did it was we said you take that and change the sign on it to a plus. So it's going to be 1. Okay, and it's going to be it's 1x to the third, or you can use this one, 1x to the third. Plus 5x plus 2x negative 8. Pull down the first one and it's a 1. 1 times 1 is 1. 5, and remember there's a plus sign here, so 5 plus 1 is 6. 1 times 6 is 6. 2 plus 6 is 8. 1 times 8 is 8. Negative 8 plus 8 is 0. So you this is an x to the third, so the first term is going to be an x squared. You go down by 1. X to the third minus, take 1 off the exponent, it's x squared, plus 6x, plus 8 with no remainder. And there you go. You get the same answer here as we got here. But if you wanted to know simply whether this is a 0 or whether this is a factor, there's another way to do it called the remainder theorem. And you can simply plug this number into the function. Well, let me draw a line and separate all this stuff here, okay? Like that. So now we're down here. So plug f of x, f of 1, into the function. So f of 1, that f of 1, again, that notation just means you're going to put a 1 in for all the x's. So f of 1 equals 1 squared x to the third, or x third, sorry, 1 to the third. Again, I'm just plugging 1 in here, plus 5 times 1 squared, 5 times 1 squared, and remember you always do the squares first, okay, plus 2 times 1, plus, or minus rather now, 8. And let's see what that is. And you don't have to do this in your head, you can write it down or do it on a calculator. 1 to the third is 1. 1 squared is 1 times 5 is 5. So 1 plus 5, let me write it down here. 1 plus 5. And then this is plus 2 times 1 is 2, plus 2 minus 8 equals 1 plus 5 is 6, plus 2 is 8, minus 8 is 0. So you see that you got 0 when you plug this number into the original equation, which is the remainder that we got in both cases. So that's called the remainder theorem. If you simply take a number and plug it into the function, whatever answer you get out of that is the remainder of a division problem of this factor right here. Okay, so let me say that again. If I simply take this and plug it into this function, which is something you've been doing for the last 2 years in math, take a number and plug it in for x, the answer to that will be the remainder if you divided x minus 1 into this. We found that when we did the long division right here, that you got a remainder of 0. We found that when we did the synthetic division here, you got a remainder of 0. So in fact, this factor does divide evenly into this number because it gives you a 0. Okay? So now what they want you to do is find the other factors. So here's our factors. I'll put them up here since I'm running low on space down there. Here are my factors. One of them is x minus 1. Again, that's not a 0, it's a factor. From this factor, we get the number 1, that number 1 right there. Okay, what are the others? Well, I have to take this or this, they're the same thing, and factor it out. So let's go ahead and do that. So I'm going to do that down here. I'm going to bring this down here. And I'm going to say the two numbers have to multiply to 8 and add to 6. Okay, so they have to, again, I'm drawing some lines to just not get things mixed up. They have to multiply to 8 and add to 6. It's a very busy problem, but that's okay. First of all, we didn't have to do long division, and I didn't have to show you this. So I'm kind of using some of the space I have down here to do this. So what two numbers multiply to 8 and add to 6? They both have to be positive. So 1 times 8 is 8, and 1 plus 8 is 9. So it's not those two that I'm looking for. How about 2 times 4? 2 times 4 is 8, and 2 plus 4 is 6. That's it. So 2 and 4 are the numbers we're looking for. So that means the factors are going to be, the factors of this are going to be x plus 2 and x plus 4. Then we had our original factor, this one that we found out by using the remainder theorem and finding out that when you plug that in, it gave you a 0. That means that this is a factor as well. Okay, so I'm going to put that number right here, x minus 1. Okay, so what are the zeros? So the zeros, or the roots, or the solutions. Okay, this one's fairly easy. What makes this go to 0, this term right here? It's x equals 1. If I put a 1 in there, this goes to 0. And that's this number here that they already gave you. What makes this go to 0? It's x is negative 2, then negative 2 plus 2 will go to 0. So it's negative 2. And finally, what makes this go to 0? It's negative 4. So after all that, you get the answer. So remember, this was just a little bit of a sideshow. You don't have to really focus on that. I wanted you to do that so you understood how, if you were given a 0, you could figure out what the factor is. So from this, we figured out that one of the factors was that. If this divided in evenly, okay. So, and we didn't have to do the long division. So what I'm going to do is just do this shortcut now. Now that I've shown you all that, I'm going to do this. Okay, what I'm going to do is redo problem 6. This is problem 6. Let's go ahead and do it so a little quicker and cleaner. So what we're saying is we want to know if the factor for which this is a root or a 0, it divides evenly into this. Because if it does, then that makes it a root, that makes it a factor of this. And so we just showed you how to determine that. The factor is going to be x minus 1. All right, that's going to be the factor of this, because it's what does this make go to 0? What factor would this make go to 0? It would make x minus 1. If you put the 1 in there, 1 minus 1 would equal 0. So these two go together. So the way we can determine that is whether this will factor out of this or whether this divides evenly into this. Another way of saying it is to plug the 1 into here. So we're going to plug in f of 1. That notation simply means you're going to put a 1 in for wherever you see an x here. So it's 1 to the 3rd plus 5 times 1 squared plus 2 times 1 minus 8. So let's simplify that. 1 cubed, 1 to the 3rd is 1, plus 1 squared is 1 times 5 is 5, plus 2 times 1 is 2, minus 8. And if we add up that, 1 plus 5 is 6, plus 2 is 8, minus 8 is 0. So it comes out to be 0. That means if we divide this into this, we're going to get a 0. And what that means is this is a factor of this. If we did that, if we could factor this out of this right here. So we know that this is a factor. So we're going to make a list of our factors here for this equation. So one of them is going to be x minus 1. Okay, now what we have to do is actually do a synthetic division to find out what the others are. So remember how you did that. You took this and you changed the sign on it to make it a positive 1, and then you divided it into the coefficients. There's a coefficient of 1 there of these numbers. So let's go down there and do the synthetic division. Okay, so it's going to be 1 divided into 1, 5, 2, and negative 8. And this is an addition here, so you're going to pull down the 1 to there, and then it's 1 times 1 is 1, 5 plus 1 is 6, 1 times 6 is 6, 2 plus 6 is 8, 1 times 8 is 8, negative 8 plus 8 is 0, so that verifies what we just said, that because that was 0, it means the remainder is 0. So let's go ahead and write this. It's going to be, you start with an x that's 1 degree less than what you started with in the original equation. That's x to the 3rd. So this is going to be x squared. It has a coefficient of 1, so you can just leave it, plus 6x. You go down by 1 on the exponent, plus 8. And that's it. So this is what you get when you divide this into this. Okay? So that's one of the factors because it has a remainder of 0. And we found that out by using the remainder theorem there. Now what we need to do is factor this. So it's got to multiply to be 1 times 8 is 8. So it's got to multiply to be 8. And it's got to add to be 6. Okay, so they're both going to be positive numbers because everything here is positive. So it's 1 times 8 equals 8, and 1 plus 8 equals 9. So that's not what we're looking for, 1 and 8. Let's try 2 and 4. 2 times 4 is 8. That's good. And 2 plus 4 equals 6. That's what we're trying to get. So the two numbers we're looking for are 2 times 4. And remember, as long as this coefficient in front of the x squared is 1, it's real easy to make the polynomial. It's simply going to be x plus 2 and x plus 4. Just those two put in a binomial. So those are two more factors, not just of this, but of the entire equation. So I'm going to put them up here. X plus 2 and x plus 4. There they are. So these are all of the factors of our original equation, this one right here. Okay, so now we want to find the zeros. So what makes this term go to 0? That's all you're asking, and the answer is 1 if you put 1 in for x. So these are the zeros. I'll go ahead and write that, also called the roots. What would make this go to 0? If x equals what? If x equals -2. And what would make this go to 0? If x equals -4. And that is the final answer for this entire problem, is to find the zeros. So again, we were wondering whether the factor for which this, if this number is actually a 0. And we find that it is. It's right there. Okay, that turns up in our final answer. But we didn't know that when we started the problem. So we used the remainder theorem to plug this in. And we saw that it came out to be, when you plugged 1 into this equation, it came out to be 0. That means that the factor that this 0 belongs to is a factor. So x, so if this is a 1, this is x minus 1, because that 1 would make this go to 0. There it is right there. There it is right there. Okay? So now what you have to do is do a division of this into this to see what the other factors are. And we did it synthetically, which is the easiest way to do it. So we came up with this from our synthetic division of this. We broke it, we factored it, broke it up, and came up with x plus 2, x plus 4. So those are the other two factors. So now we just simply ask what makes each of these go to 0. Those are the numbers, and so that's your final answer. If this is tricky, I would practice it a few times to see if you can do it on your own. You don't need to get a bunch of new problems. Just do this a few times until you can do it without looking at these notes, without looking at this solution, okay? All right. Let's keep pushing on here. And we're going to do number 7. So use the remainder theorem to determine if the following are roots to the given equation. If so, now this is a big if. If it is, find the other roots. So what we're going to simply do is plug 2 into this and see what we get. If we get 0, then that means that what's the factor going to be that this would be associated with? It would be x minus 2. It means that x minus 2 is a factor, and there will be other factors that we can find. But first we need to test this. So we're going to say f of 2, meaning you're going to plug 2 in where you have any x, is going to be 2 to the third, I'm just following the equation, minus 2 times 2 squared, I'm just plugging a 2 into there, plus 9 times 2, plugged a 2 into there, minus 10. Let's see what that comes out to be. 2 to the third is 8, minus 2 squared is 4 times 2 is 8, plus 9 times 2 is 18 minus 10. What does that equal? Okay, 8 minus 8 is 0, plus 18 is 18, minus 10 is 8. This does not equal 0. That's a does not equal sign. Therefore, this is not a factor, and therefore, here's the good news. You're done with the problem. You can't do anything further to factor this. Unless we have a way to divide this into this and come out with an even answer, come out with an answer with no remainder, in other words, you can't go any further. So the bottom line is this. If when you plug this 2 in here, it doesn't come out to be a 0, it didn't, it came out to be an 8, you're done with the problem. So I'm just going to write the word done. Okay, we're done with the problem. Okay, so let's write y. X minus 2 is not a factor. I'd like you to write this out. I want to be sure you understand the explanation. So, no further. So x minus 2 is not a factor. So no further factoring is possible. Okay? All right, we're going to move on. All right, we're going to move on to 8 here. I don't know where this 14 comes from. We're going to move on to number 8 right here. So here we have a function. They're asking us to do some graphing here. Okay, and so they say what I know about this function. Well, it's a difference of squares right here. So this is a perfect square and x squared is a perfect square. So it means we can use the following. A squared minus b squared equals a plus b times a minus b. So first we have to figure out what a and b are. So what you have to do is come here, a squared minus b squared. So put a parenthesis here, squared minus parenthesis squared. We've done this before. What goes in here to make it equal to 9? And the answer is 3. 3 squared would equal 9. Minus what goes in here to make it equal to x squared, and that would be x. So that was pretty easy. So 3 is equal to the a in this equation right here, and x is equal to the b. By the way, you might notice this is not standard form. Standard form, the x squared term would go to the left, and then the 9. So it would be negative x squared plus 9. But it doesn't matter. We can still work with this, okay? So what that means is if you factor this, it's going to be a plus b, so that's 3 plus x, times a minus b, that's 3 minus x. So this is the factored form of this. Now what they're asking you here is as x goes to, I know this math notation sometimes drives you crazy. So what it's saying, let's do this one first, okay? It makes more sense for this one to be first. As x goes to infinity, so this is my x-axis. As it goes to infinity, so it's heading in the direction of that infinity is called the lazy 8 sign. It's a sideways 8. As it goes in the direction of infinity, what does f of x do? Does it start getting higher? Does it start going up? Does f of x start going up? Or does f of x start going down? Okay, so we're trying to figure out what's f of x going to do. Okay, so as this goes in this direction, does the f of x, basically the y, go up or down? Okay, that's what we're asking. Then this one is negative infinity. As it goes backwards, goes towards -1, -2, -1 million, -10 million, keeps going in this direction. So in this direction is negative infinity. What does f of x do? Does it go up or does it go down over here? That's what they want to know, and that's what that math notation is asking you for. So what we're going to do is we're going to plug this in, we're going to plot this on Desmos, okay? And we're going to go ahead and plot both this and both this. So you've probably used Desmos before, almost certainly, so I'm going to switch over to Desmos now. Okay, so the way you can get to Desmos is just go to Google. It's Desmos. If you want to be sure you go to the right site, put desmos.com, and you could have put that up here. And we're going to go to Graphing Calculator, the very first link right there, and there it is. Okay, so you've probably used this before. You can type in from your keyboard, or you can open up this little keyboard icon down in the lower left, and it will give you numbers and symbols that you can punch in. Okay, so I'm going to close that. I'm just going to type in from my keyboard. So the equation we have is 9 minus, and actually I do need to use this keyboard down here, x, and then I hit the a squared right here, if you see where I am, and that makes it x squared. Okay, and I'm going to close this. And one thing you can do with Desmos is, first of all, I could just zoom out. In this case, that's all I need to do to see what that function looks like. And also you can grab it and slide it up and down and slide it around, okay? So it's a parabola because it's an x squared term, and since there's a negative sign in front of the x squared term, it's going to be a frown face, a downward curving parabola, okay? There's also ways that you can change the scaling, but we don't really need to do that here, so I'll deal with that when we get to it. Now, what I can do is put in a second equation. I'm just going to hit enter, and it gives me a place to put in a second equation, and we're going to put in the factored form that we just came up with on our own here. 3 plus x, parenthesis, whoops. I didn't do that at all right. Let me try that again. 3 plus x, and I should have put parenthesis in front and parenthesis after, and now begin parenthesis, and it's 3 minus x. That's what we got when we just factored, closed the parenthesis, and you notice you got a blue line. They're overlapping each other. So if I turn them both on at the same time, actually they are both turned on at the same time. If I turn off the red, I just see the blue. Now the red is turned off. I'm going to turn it back on. Now I'm going to turn off the blue, and now you see the red. So in other words, you've got two curves that are exactly the same. What that verifies is that these two equations are exactly the same. All right, and what I'd like you to do is just sketch this. It doesn't have to be perfect. You notice that it goes through what the intercepts are here is about. Well, you can figure it out here. Well, actually, we factor it and we figure out what the zeros are. It's going to be plus 3 and minus 3. Why? Because minus 3 makes this term go to 0. 3 minus 3 would be 0, and plus 3 would make this term go to 0. See what happens if we put an equals 0 in here. I'm not sure it's going to like that. It's just showing you straight lines here that are going through the x-intercepts. And here's what you can do. You don't even need to do that. Let me come over and take that 0 off. If I put the cursor so it turns into a little finger right over that, it tells you that that point is negative 3. And if I do it over the other point, that point is positive 3. Now you could have done this without using Desmos, but Desmos is a nice way to do the graphing. Okay, so what we're going to do is go back to our original sheet and finish this problem. By the way, what is the y-intercept up here? And you can see it's 0, 9. Okay, 0, 9 is the y-intercept up there. Okay, so let's go ahead and go back to our... Okay, so if we plot that, it went through 0, 9, that's up here. That's the dot right there. And it went through negative 3, that's right here. And it went through positive 3, that's right here. So you have 3 points. It just takes 3 points to define a parabola. And so it came up. I kind of missed my point there, but it should have gone through there. And then it comes down like that. Okay, let's just kind of fudge that a little so that point goes there. So that's what you saw on Desmos. So what it's saying is, as x goes towards, let's do the second one first. As x goes towards positive infinity, as this goes further and further this way, this goes further and further down, okay? In other words, as you go from here to here, you're right there. As you go from here to here, you're right here. As you go to 3, you're right there. As you go to 4, you're going to be down here somewhere. 5 is going to be down. So it's going to go down. So what that would be is f of x approaches negative infinity. In other words, going down on the y-axis is negative infinity. If it goes down forever, it goes to negative infinity. Now, if you go in the negative infinity direction, that's what this one is asking, it's also going to go down. So as we're here at this point 0, we're here. At 1, we're right here somewhere. At 2, we're right here somewhere. At -3, we're right here. -4, it goes down and down and down. So this also approaches negative infinity. Okay, as this goes this way, the x-axis, the x-coordinate goes this way, the y-coordinate continues to go down, 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 down forever and ever. Okay, so they're both approaching negative infinity, whether you go in the positive direction or negative direction. Okay, and that's the answer to number 8. Let's move on. Okay, so now they give you an equation. What I know about this function. Okay, and then ending behavior, it's the same kind of thing. So let's go back to Desmos. Okay, so I'm going to type in the function they showed, and it was x plus 1. Oops, not typing. Let's do that. X minus 1 and x plus 2. I'm getting this straight off of the problem. Okay, there it is. All right, this is a cubic. So you know this is a cubic because if you expanded it, your first term would be x times x times x. That's x to the third. And a cubic function has this shape. Let's put it down here. Okay, it has that shape. It comes up, it goes back down, and it goes back up. And remember how many zeros a cubic can have? Not all of them have this many, but it can be 3, up to 3 zeros or roots. So notice at -2, it passes through the x-axis. That's called a zero or a root. Right here at -1, it passes through the x-axis where I'm circling. And right over here at +2, it passes through the x-axis. So the zeros are -2, -1, and 1. Again, you don't see the -1 there, but it's there because you know that because this is -2 and this is 0, so that's got to be -1. That's 0 and that's 1. All right, so the zeros are -2, -1, and 2. Excuse me, +1. That's a +1 right there where I'm circling. All right, so how do we know those are the zeros? Well, look up here. What would make this first term go to 0? A -1 would. -1 plus 1 would be 0. So there's the -1 right there where I'm pointing. What would make this second term up here go to 0? A +1. +1 minus 1 would be 0. So there's the positive right there where I'm pointing to. And finally, what would make this term go to 0? It would be a -2. -2 plus 2 would be 0. And there's the -2. So the zeros are exactly where they should be. All right. We also see that it has a y-intercept at -2 down there. So now we can go back and we can sketch that on our graph. Okay, so right away we can go ahead and write the zeros here. This one's going to be -1. This one's going to be +1. And this one's going to be -2. So that's where it's going to intersect the x-axis. So it's going to do it at -2. On the way up, it's going to do it at -1 on the way down, and then it's going to do it at +1 right here on the way back up. Okay, so it's going to look something like this. Curve back down and curve back up. And it went through the y-axis. I should have pointed that out as I did it, through -2. So that's exactly what you saw on Desmos. Okay, what I know about this function, it's a cubic, and it has a cubic width. With 3 roots or zeros. Again, those two words mean exactly the same thing. And there's the 3 roots and zeros. Okay, so now it's asking, again, I'd rather do positive first. If x goes to positive infinity, what happens to h of x? Again, h of x just means y. What does it do in the y direction? So as this goes towards positive infinity, as this goes further and further right, this goes further and further up. So it's as x goes to positive infinity, y, or h of x as they call it, goes to positive infinity also. So it's going to go towards positive infinity. What is h? Why do they use h? Because they just picked a letter. You can pick any letter to name the function. It just means basically the y variable. Okay, what about as x goes to negative infinity? Okay, so over here is negative infinity. So as x goes in this direction to the left, what happens to this? It goes down and down and down and down, so it heads down towards negative infinity. This one was going up to positive infinity. This one's going down to negative. I wrote an 8. That should be an infinity sign. Negative infinity. Okay, so this will be going down. And I'll just write that word just to be clear, down. And this one was up. Okay, so that's all they're asking you to do on these, all right? So that takes care of this lesson. It's due Friday. It's not a long lesson. And you can go ahead and finish this up and try to turn that in by the end of the week, okay? All right, have a great day. We'll see you in class.